we're heading into our next section. And hey, see me. And there's Mrs. Rowland back there. Hi, Mrs. Rowland. So I said that I was going to try to put my face in here, which is kind of weird, but apparently it's a thing you're supposed to do. I don't know. So, hey, do you see my face? It's kind of weird. But we're doing our next section, which is measuring and constructing angles. So the first piece, again, and if any time, maybe pause me, write the stuff down, and then we can kind of come back and highlight, but I'll explain as we go. This is an angle, and an angle is made up of two rays, and they have the same endpoint. That endpoint is called a vertex. So here's an angle. You know what an angle is. An example of this angle, of how to name the angle, there's a couple different ways I could. So I could just call this angle 1. Sometimes they put a number in this little corner, so I could call this angle 1. I could also say this is angle CAB, or I could call it angle BAC. Notice the really important piece is this right here. This vertex, or the kind of like the hinge, needs to be in the middle. So when I name that, I could switch it around and say BAC or CAB, but A has to be the guy that's in the middle. So that's how I name it and know where that hinge piece is, or where the vertex is. All right, in this next piece, they're going to talk sometimes about an interior or the exterior of an angle. So we know from our past that interior means inside and exterior means outside. Our first postulate for the day is postulate 1.3, and it's called the protractor postulate. It's very similar to the ruler postulate, if you remember that, which is kind of silly. It just says, I can use a ruler to measure a line segment. Well, the protractor postulate says, I can use a protractor to measure an angle. So a quick review of your protractor. This is really not a very nice picture of a protractor, but I think you get the idea that on the end, we see 0 degrees, and all the way on the other end, we're going to see 180 degrees, okay? So this goes all the way around that semicircle, that half of a circle, and in each space, they're going to talk about the degrees, okay? I just wrote down the basics. This is 0, halfway is 90 degrees, and the whole way is 180 degrees. So again, the protractor postulate is just saying that if I have an angle, I can put my protractor on top of it, and I'll be able to measure. A couple of things when you're measuring is to be really careful that you don't actually use the bottom of the protractor. You need to use this line right here. There's kind of like this thin, skinny little line here, not the very bottom of the protractor, but it's wherever the 0 and the 180 are lying, not this very bottom piece. So notice my little angle here is not on the bottom of the protractor, it's right here where it lines up with 0. And then right here, I'll be able to see what degree measure that is. Now, a quick reminder to angle types. I know you've seen these before, probably tons and tons of times, but it's going to be helpful to just jot these down in our notes because there's going to be some questions on them, and sometimes it just helps to see a quick picture. So again, we know acute is less than 90 degrees. It's cute, it's little. Right angles are equal to 90 degrees. Obtuse is larger or bigger than 90 degrees. And a straight angle is like a straight line, which equals 180 degrees. So it's maybe a little bit of a pain, but I think it would be really good just to jot these down and a quick little picture. The next postulate today is postulate 1.4, and it's called the angle addition postulate. Very similar again to the segment addition postulate, where I take two pieces and I add them together to get the whole. So the same thing is happening with this one. I have angle RSP, so it's this guy right here, RSP, which is this one. And if I add that to angle PST, that's this one right here. If I add these two pieces together, I'm going to get the whole piece. Now I just need another color here. Here we go. So I'm going to get the whole thing, RST. So I'm going to get that whole piece. just like segment addition. The two little pieces together equals the whole big piece. Here is an example of what we're going to see. So here I can see the given has told me that KLM is a straight angle, meaning this guy right here is a straight line, which again tells me something, right? A straight angle or a straight line is equal to 180 degrees. And together, I can see that this angle plus this angle is going to equal that whole piece. So we're going to set that up together. I'm going to say that KLN, so this guy right here, which is 10x minus 5, this piece, plus this piece, this NLM, that 4x plus 3, is equal to a straight angle or 180 degrees. So you can see each piece is set up. So this piece plus this piece equals the whole piece. And what our goal is to find, they want us to find each of the angle measures. So they want to know how big is this angle and how big is that angle. So I have to use a little bit of algebra. So if you remember, I'm going to add both of these together. They're on the same side, so I want to put them together. I'm not going to move them across that border. I'm going to add them together. So I took 10 and 4 to get 14x. And then I took the negative 5 and the 3 together, and I got negative 2. Now it's a two-step equation, and I can go through and solve it. I'll add 2 to both sides. I'll get 14x is equal to 182. And finally, I'll divide both sides by 14, and I get 13. Now remember, they didn't ask me to find x. They asked me to find these angle measures. So I'm going to have to take x and put it in and substitute in order to find these angle measures. So below, I did that. So here's the example of that. Remember that first angle was equal to 10x minus 5. So I put 13 in, I multiplied, and then I subtracted, and I got 125. The other angle, if you remember, is 4x plus 3. So I replaced again the 13, which we found. I multiplied, and I added, and I got 55. I also noticed, just did a quick little double check. If I add both of these together, it should equal 180, and it does, which is a good thing because remember, straight, it makes a straight angle or a straight line, which is 180 degrees. All right, the last part for today is the angle bisector, and it works very similar to the segment bisector. It's going to take an angle, and it's going to bisect it. It's going to chop it in half. So this is our chopper. Remember, Mrs. Rulin was our segment bisector. Now we have an angle bisector. So this guy right here, this ray, WY, is our Mrs. Rulin. That's the chopper. This ray bisects XYZ, which means it creates two equal pieces. So again, if I used it in algebra and I said like this is 30 degrees, then I would know that that's 30 degrees or whatever they want us to solve. I know I have two equal pieces. Well, our video is a little bit longer today, but we had so much interesting information to write down. So if you made it all the way to the end, I'm so proud of you. We have a bonus feature today. So here is the bonus. My favorite soda or pop, whatever you want to call it, is Coke. Mrs. Rulin's is Dr. Pepper or Mr. Pibb. What's your favorite? So you need to come tell me or you need to come tell Mrs. Rulin and you will receive a bonus.